We're starting into chapter 7. We're in 7.1. Today, we're going to talk about rectangular prisms. Surface area and volume of rectangular prisms. Mostly stuff that we've seen before at one time or another, one way or another. So some of this is going to be a little bit of a review. We're just going to go into a little more detail. So we're going to talk about surface area and volume. And today we're talking about right rectangular prism. And right rectangular prism is a fancy way of saying what kind of shape. What's an everyday word we use for right rectangular prism? A box. So we're talking about boxes today, essentially. So let me grab a picture of a box, and we'll talk about the surface area and the volume. So there's my box. We're going to say that the dimensions of the box, just like we did the other day, L, W, and H. It doesn't matter what side we call L, the length, which side we call the width, which side we call the height. We can switch them all around, just as long as we get one side labeled each way. So we're talking about a right rectangular prism, the surface area. And we usually write surface area as with S. Our formula for surface area, 2 length times width plus 2 width times height plus 2 length times height. Now, the formula looks a little confusing, but all we're doing here is we're adding up, and I'm going to put a little note down here, we're just adding the area of each side. So you don't even have to memorize a formula. All we're doing for a box, for a right rectangular prism, is adding the area of each side. So I have two sides that are length times width, the top and the bottom. I have two sides that are width times height, the front and the back. Two sides that are length and height, the left and the right side. So all we're doing here is adding up the areas of each side of the box. That's what the formula is telling us to do. So you don't have to memorize this formula. Just remember that we add up the area of all the sides. The volume, and before we talk about volume, our units are units squared. So surface area is an area. We're talking about units squared. Our volume for a box, L times W times H. We're just multiplying the length of each side, and our units are cubed. And this, we've, at one point or another throughout school, you've worked with these formulas before. We know how to find the area of a box. We know how to find this, or the volume. We know how to find the surface area. We just add the areas of all the sides. So questions on our formulas. All right, let's do a quick example. So a box that has dimensions 6 centimeters by 8 centimeters by 12 centimeters. Well, can it be a cube? No. Because all the sides aren't the same. In order for it to be a cube, all the sides have to be the same. We want the surface area and the volume. So we're going to, for the volume, let's do the easy one first. The volume is going to be 6 times 8 times 12. I calculate that out, and I get 576 centimeters cubed. The surface area. I have two sides that are 6 by 8. So 2 by 6 by 8. I'm going to add that to two sides that are 6 by 12. Plus two sides that are 8 by 12. That should be a plus, that should be a times. 8 times 12. And I get, this equals 96 plus 144 plus 192. When I add that all together, I get 432 centimeters squared. So my volume is 576 centimeters cubed, my surface area 432 centimeters squared. Just plugging in and calculating. So questions on that one? Shouldn't be anything surprising, shouldn't be anything groundbreaking. All right, let's talk about cubes. Preston mentioned cubes, so let's talk about cubes. So what is special about a cube?
All sides are the same.
All the sides are the same. So because all the sides are the same length, that makes our formulas a little easier. So let me draw a cube here really quickly. And I know my cubes don't turn out perfect. So we might have to use our imaginations a little bit. So here's my cube. And we're going to call the side length S for side. S, S, and S. The surface area. We talked a little bit about the surface area of the cube already when we did our little drawings. When we found the surface area of our cube that had the side length of one side, what we did was say, let's find the area of one face of the cube, one square. So if this square is S units by S units, what's going to be its area? S, well, and our base is S, and our height is S. So how do we find the area? S times S. So S times S is S squared. So the area of one of these squares is S squared. How many squares do we have all the way around the cube? 6. So our surface area is going to be 6 S squared units squared. Find the area of one side of the cube and add 6 of them together. And I'm going to make this S just a little bigger for surface area. So our surface area is 6S squared, and our volume, V, equals my length, my width, and my height are all S. So what do I get when I multiply S times S times S?
S cubed.
S cubed. S cubed units cubed. So our formulas get a little simpler when we're talking about a cube. But again, the surface area, we're just adding up the area of each side. The volume, we're multiplying length times width times height. That's all we're doing. So let's look at a quick example with a cube. We have a cube with a side length with a side of 5 inches. We want the surface area and the volume. So we're going to say our surface area is 6 times the side length squared. And when I multiply that out, I get 150 inches squared. My volume is just going to be 5 cubed. And 5 cubed is 125 inches cubed. Now, sometimes we'll have to go from the volume to the side. So if I knew that the volume was 125 inches cubed and I wanted to find the side length of my cube, to undo a cube, I have to use a cube root. So in your calculator, you're either you're going to have a button that looks like this. Then you'll have to do the cube root instead of the square root. So on problems where you're undoing a cube, you have to do the cube root. If you can't figure out where it is on your calculator, I can help you out with that. All right. Let's look at a slightly more complicated example. Let's say we have a cube with a surface area of 120 centimeters cubed. And we want to find the volume. Well, what do we need? What piece of information do we need to find the volume here? What goes into our formula to find the volume of a cube? The side. We need to figure out the side length. When we have a problem where we have the surface area where we have the volume and we need to find the side length, what we need to do is plug what we have into the formula. And calculate what we need. And rather than calculate, I'm going to say solve for what we need. So we did these kinds of problems when we talked about area, where we have the area of the circle, we wanted to find the radius, that kind of thing. It's the same idea. We're going to plug in what we have and solve for what we need. We know the surface area is 120. 120, and we know our formula for the surface area is 6s squared. So 120 equals 6s squared. This will let us find the side length. So I'm going to divide by 6 and turn my equation around. I get s squared equals 20. To find s from s squared, what do I do? Square root. Square root undoes the square. And I get that, I'm going to go up here. S, our side length, is the square root of 20. I'm going to plug that in my calculator. So the square root of 20 comes out to be 4.47, about 4.47. And then I can plug the side length, and now I can plug that into my volume formula and find the volume. So the volume is going to be 4.47 cubed, and I plug that into my calculator, and I get about 89.3. And it's going to be centimeters cubed, and this should be centimeters squared for my surface area. So I need to find my side length first by plugging into the formula and solving for the part that we're looking for, and then use that information to finish solving the problem. And this kind of problem shows up a lot in homework, on quizzes, and on tests. All right, questions on that example? Okay, last thing for today. Surface area to volume ratio. Surface area to volume ratio is an important thing for a lot of science. We need to figure out the surface area to volume ratio, and we use surface area to volume ratio to explain why things are shaped the way they are. And we'll talk about that in just a second. So the surface area to volume ratio for any shape, for any polyhedron, we're talking about solid shapes, all we do is take the surface area and divide by the volume. Surface area to volume ratio just means find the surface area, find the volume, divide the surface area by the volume. That's all we're talking about. So if we wanted to calculate, do a quick example. So we have a box that is 7 by 3 by 5. Some kind of units. So we have a box that's 7 by 3 by 5, and we want to find the surface area to volume ratio. So we're going to calculate the surface area, calculate the volume, and then divide the surface area by the volume. So my surface area is plugging into my formula, or remembering I'm taking 2 times the area of each side. 2 times 7 times 3 plus 2 times 7 times 5 plus 2 times 3 times 5, which when I calculate this out is 42 plus 70 plus 30, and I get 142. And my volume is just 7 times 3 times 5, which is 105. And my surface area to volume ratio is just S divided by V, surface area divided by volume, 142 divided by 105, and I get 1.35. So my surface area to volume ratio is 1.35. And usually we just drop the units for surface area to volume ratio. So questions on surface area to volume ratio. Now the kind of questions that the homework asks you is it will ask you to try and use surface area to volume ratio to explain the shapes of things. So for example, it might say why on a plant is a leaf wide and flat. Using surface area to volume ratio, why would you want the leaf to be wide and flat? And you could say you want a large surface area because the leaf is trying to collect sun. So you want a large surface area so the leaf can collect the most sun. So it might ask you why you would break up a big chunk of ice to make it melt faster. And you could say, well, if you break it up, you increase the surface area of the ice so that the heat can get to it better. So that's the kind of questions that the homework's going to ask you about surface area to volume ratio. If you're building a box, do you want to maximize the volume or do you want to maximize the surface area? Well, if you're building a box, the material that you use to make it costs money. So if you make the surface area really large, it's going to cost you more money to make the box. So you want to make the volume larger for as small amount of material as you could. So you'd want to maximize the volume for the amount of material that you use. So those are the kinds of questions that that the homework's going to ask you about surface area to volume ratio. So try to think about why you would want a certain shape to have a large surface area or a large volume. Questions? All right. Pass your folders back. We'll go over the homework.